Welcome to today's Explainer. We've got an incredibly fascinating journey ahead of us. We're taking a deep dive into the true science of sleep, biological timing, and cognitive performance. If you've ever felt like your brain is just running a step behind even when you swear you did everything right with your sleep, well, you are in the exact right place. We're going to look at some groundbreaking data that literally turns our traditional understanding of rest completely on its head. So let me ask you a question. Is sleeping in on the weekend actually ruining your Monday cognitive performance? Think about a child you know, or hey, maybe even yourself. Have you ever noticed this incredibly frustrating paradox where someone can spend 10, maybe even 11 hours in bed, and yet they wake up just utterly exhausted, cranky, and completely unfocused? You're probably thinking, but they got so much sleep. Well, what if the total hours spent lying on a mattress isn't the whole story? What if the brain is actually fundamentally misaligned? Section 1. The myth of sleep duration. Why more time in bed isn't the fix you think it is.
Okay, let's dive right into this. For decades, the mainstream conversation around fighting fatigue has been incredibly simple, almost dangerously so, really. The advice is always just spend more hours in bed, right? If you're tired, go to sleep earlier. If you're absolutely exhausted by Friday, just sleep until noon on Saturday to, catch up. But the data reveals a hidden variable in our biology that renders simple sleep duration almost totally irrelevant if it's not managed. To understand this, we need to clearly define our main villain here, a phenomenon called social jet lag. Social jet lag is the discrepancy in your sleep timing patterns between your school or work nights and your weekend nights. Listen, it is not about how long you sleep. It's entirely about the shifting of the timing that just violently throws off your internal biological clock. Think about it this way. When you shift your sleep schedule by 3 hours on a Saturday, your brain experiences the exact same biological stress as if you just literally flew across 3 time zones.
And a major study out of Johns Hopkins University looked at exactly this. They studied 350 children aged 5 to 12 who were diagnosed with ADHD. Now, the researchers measured 3 specific things: time in bed, general sleep disturbances, and social jet lag. And the twist in their findings is absolutely remarkable. After adjusting for all the socio-demographic variables, they found that time in bed and general sleep disturbances actually had very few associations with cognitive performance. However, social jet lag, that was directly and negatively associated with how well these children's brains actually functioned. To put a precise number on this, the researchers found a beta coefficient of negative 0.22 specifically for language-based reasoning. Now, what does that actually mean? Well, this specific number represents a steep, statistically significant decline in a child's ability to process and reason through language, caused entirely by the shifting of their sleep timing on the weekends. The hours they slept didn't save them. It was the shift in their schedule that penalized them. And this brilliantly illustrates the full scope of the damage. The Johns Hopkins data shows exactly how cognitive abilities drop when our rhythms misalign. Processing speed, that took a major hit at negative 0.20. Visually based reasoning dropped by negative 0.13. And like we just saw, language-based reasoning fell by negative 0.22. Guys, this is heavy impact data. It shows us that when the internal clock gets confused by those weekend sleep-ins, the brain literally slows down its ability to process the world around it. Moving on to Section 2, the brain's daily gating. Let's take a look inside the biological clock's engine room. So why exactly does this happen? To really understand why timing trumps duration, I want you to think of the human brain as a massive, incredibly complex orchestra. You can have the most well-rested, talented musicians in the world, but if they don't have a conductor keeping the timing, all you're going to get is noise. Your circadian rhythm acts as this crucial conductor, especially in the areas of the brain that handle focus and memory. Let's zoom in on the specific cellular mechanisms inside the prelimbic prefrontal cortex, or the PLPFC for short. This area is absolutely vital for working memory and behavioral flexibility. Get this, the pyramidal neurons in layers 2 and 3 of this region literally change their firing thresholds based on the time of day. It's wild. During phase 1, the rest phase, the resting membrane potential of these neurons actually depolarizes. Then, in phase 2, the active phase, they hyperpolarize. This basically means the actual electrical sensitivity of your brain cells fluctuates rhythmically over a 24-hour period. Research into circadian biology describes this phenomenon beautifully. It says intrinsic or diurnal gating regulates the flow of information and prevents the saturation of synaptic circuits. Now, really think about what that implies for a second. Even if your neurons are perfectly well rested from, say, 10 hours in bed, if you're asking them to perform during their biological rest phase, just because you shifted your schedule, this crucial gating mechanism fails. The information flow becomes totally chaotic, and your synaptic circuits basically become saturated. In everyday life, you experience this as brain fog, slow processing, and a total lack of focus. Section 3. Bipolar and the clock. Let's look at pushing the biological clock to its extremes. Let's move to and see how this all builds when we look at extreme cases. What happens when these biological clocks, these cellular gating mechanisms we just talked about, are pushed to their absolute limits? Well, bipolar disorder actually gives us a powerful window into the biology of rhythm. The overall heritability of bipolar is massive, estimated at anywhere from 79% to 93%. But here's the key. The genetic links are heavily tied to rhythm. Studies have found abnormalities in specific circadian clock genes in those with the disorder. And furthermore, purely environmental disruptions to rhythm have severe consequences. Simply put, sleep deprivation acts as a massive trigger, actually inducing manic episodes in approximately 30% of cases. The biological clock is so deeply integral to emotional regulation that disrupting it can literally trigger a psychiatric event. Now, what's really interesting about this next piece of data is how cleanly the vast neurological data we have on this condition actually maps out. Researchers link specific symptom dimensions directly to functional brain abnormalities. So, when patients experience disorganization, we see hypofunction in the ventrolateral and medial prefrontal cortex. What about reality distortion? Well, that maps to functional abnormalities in the amygdala and hippocampus. And psychomotor poverty links right back to the ventral striatum. It's this complex prefrontal striatal palliothalamic limbic network that completely relies on timing. And when it misfires, specific emotional and cognitive anchors just break down. We even see a truly fascinating lateralization of the disorder depending on the mood state. For instance, bipolar depression is generally associated with left hemisphere abnormalities, conservative decision-making, and hypometabolism in the dorsolateral prefrontal cortex. But on the flip side, mania is associated with the right hemisphere, much more liberal and impulsive decision-making, and hyperactivity in the amygdala. It's the exact same brain network, but it's misfiring in entirely different directions, pulling the patient to either extreme. And all of this is deeply intertwined with their daily biological rhythms and sleep patterns. This brings us to a really compelling concept known as the Kindling model. Originally, this was used to understand epilepsy, where seizures require weaker and weaker electrical stimulation over time to trigger them. But now, this model has been applied to mood disorders. The basic idea is that major environmental stressors, like severe sleep deprivation or trauma, trigger the initial mood episodes. But as these disruptions to the brain's rhythm keep occurring, the emotional circuitry actually becomes permanently more vulnerable. So over time, progressively weaker triggers can precipitate a full affective episode. It's almost like the initial damage to the biological clock makes the brain increasingly fragile as time goes on. Section 4. Realigning your mental rhythm. Here is the critical takeaway for your brain's conductor. So the absolutely crucial point here is this. From managing the day-to-day processing speed of a child with ADHD, all the way to understanding the profound mood shifts in bipolar disorder, timing is just as critical as rest. We simply cannot just look at hours slept as the sole metric of brain health anymore. We have to look at the consistency of our internal conductor. When we shift our schedules, we are shifting the cellular gating of our very neurons, and we're risking synaptic saturation and a real loss of cognitive control. Which leaves us with a pretty critical question to ask ourselves as we wrap up today's explainer. Is your weekend routine throwing your brain's orchestra completely out of sync? The next time you think about sleeping in on a Saturday, just to catch up, remember the pyramidal neurons in your prefrontal cortex. Remember social jet lag. You might be resting your physical body, but you could be deeply, deeply confusing your brain. Thank you so much for joining me on this incredible look into our biological clocks, and I really hope this helps you keep your mind's orchestra playing perfectly in time.